Okay, this lesson is the second part of Chapter 5.2, exponential equations, solving for x in these exponential equations. We have this example of 25 to some power x we don't know equals 125. Okay, so they wrote it again. And the key to doing this problems is, the key to solving these problems is this next step here is writing these two sides of the equation with the same base. Okay, so if we can do that, and then that's a lot, they have only certain problems that this works, and the problems you're going to have for homework are, contrived of this type, so you can write them with the same base, but it may not be that obvious when you first look at it. You can see now, of course, when you have the screen pulled down, that 25 is 5 squared, and 125, you may not remember, it was 5 to the third power. Okay, so they rewrote that with the same base of 5. Both of these have the same base of 5. And then using the powers of exponents, 5 to the second power to the x power is 5 to the 2x power. So both of these sides of these equations now have the same base, and they're both equal to each other. So that means the exponents must be equal to each other. So we set the 2x equal to 3, solve for x, we get x equals 2/3. And if you put in your calculator 25 to the 2/3 power, you're going to get 125. Okay, and remember that 25 to the 3/2 power is like the 2 on the bottom is the same thing as the square root of 25 to the third power. Well, the square root of 25, of course, is 5, and 5 to the third power we just did is 125. Okay, so now we're trying a different one. Solve for the value of x. So we've got 1/3 and we've got 81. Okay, so this is a little tougher problem. And always the first part of it is right with the same base, where it takes some intuition, some thinking about what's going on here, how can I get these to be the same exponent base? Okay, we've got a fraction here, 1/3, and we've got 81. Well, the key is to remember that 81 can be written as a power of 3. 3 times 3 times 3 times 3, or 3 to the 4th power. And 1/3 is the same as 1/3 equals 3 to the -1 power. So I'm going to rewrite this as 3 to the -1 to the x equals 3 to the 4th power. So I've almost got those equal to each other. And I use the power of exponents to multiply -1 times that. So 3 times -x equals 3 to the 4th. So then we get these two exponents have to be equal. I've got them to the same power. So -x equals 4, or x equals -4. Okay, so remember, when you have a negative exponent, it's like dividing. So if I divide by 1/3 4 times, I'm going to come up with 81. Okay, this next example is a little even more tricky than the other one. I mean, the problems in the book are not going to be quite, these would be the hardest ones you would do in the book, would be ones like this. Okay, so 27/8. We can kind of think of that as this, okay, 27 is one of those powers of 3. 3 times 3 times 3 is 27. 2 times 2 times 2 is 8. So I kind of get the idea that I can write this as 3/2 to, and I'm going to write that 3/2 to, I'm going to rewrite that again. Didn't like how that came out. Okay, so I'm going to rewrite 27/8 as 3/2 to the third power. All of that to the x. Okay, so 2/3, 3 times to the third power is 27, and 3 to the second power is 8. So I can rewrite it like that. What about the 1.5? Well, 1.5 is just a decimal equivalent of 3/2. So I can rewrite that as equal to 3/2 raised to the x plus 1 power. So work my algebra, my exponent magic on that. I get on this side, this equals 3/2, oops, 3/2 to the 3x power. So then I have put these two exponents equal to each other. So 3x equals x plus 1, 2x equals 1, x equals 1/2. Okay, you can check these answers back in your calculator, right? If I put an x equals 1/2 here and I put a 1/2 here, I'm going to get 1.5 to the 2.5 power and this fraction to the 1/2 power. You can check that in your calculator and make sure that that is indeed the case. But the real trick here, of course, is getting these bases to be the same. And it's the problems in the book, this would be like one of the hardest ones in this one. So try those. If you have trouble in class, we can go over it in class. Inequalities, graphing to solve inequalities. Okay, so we have this graph here of the same exponents we had in there, and they say where is the graph of those things equal to 0? Okay, so to do that solution, you have to put it in your calculator, right? You put it in your calculator. Where is this is the y1 equals, put that in your calculator, graph that. And they use this window here. You can use the 10, 10, 10 window. It's fine. But you have to figure out where this 0 is. Okay? So you guys remember how to do that on your calculator? Oh, I don't have the calculator going here. Let me get the calculator going on my computer here. I don't know why I don't have it going. Okay. All right. So we do that. Remember how to do the calculations to find 0. You do the second calc menu, and number 2 is 0. You use that to find the 0 of the graph. Okay, so I didn't want to close it. So we put that down there for the moment, and darn, I didn't want to close it. Okay, so you can do that on your calculator. We have a few of these problems to do for homework tonight. But basically, you want to figure out where this graph is above this 0 line. And you calculate where the 0 is at 0.5. So the solution set is, and remember, a lot of times students get this backwards. They put 0.5 to negative infinity because they're looking at the 0.5 there. But we always put the lowest number first. That goes first, negative infinity to 0.5. Okay, we're going to talk about the natural number e. This is a little key on your scientific calculators. Maybe you've been wondering what it's been for. Maybe you used it last year in Algebra 2. But it's named after the mathematician Leonhard Euler. That's how you say his name. I forgot for a second. Euler's how you say his name. And he came up with this. If we use a little calculus here to as x approach, we have this function, this little exponential function here. And when x gets very large, this value of this function approaches this number e. E is like pi. It's an irrational number, but it's very important, like pi, and the calculators have that on there. And they show down here, they show the function of what it looks like graphed. Okay, so it's a power function, looks like that. Compound interest. Okay, we're going to do a few compound interest problems. I'm going to go over what exactly is in compound interest because these involve exponential functions to do that. And interest equals P times R times T, where P is the principal, R is the rate of interest in, and T is the number of years. That's simple annual interest, and A is the amount of the final balance. Okay, so pretty much how we do the interest on this one is the amount equals the principal plus whatever interest you got, the principal times your rate, and then we would add that principal to add the interest you earned. This is the interest you earned, the principal times the rate, and the time they left off the time because it's just 1 year in this case. So we would add that together at the end of 1 year. We'd add your interest you earned to your principal, and then the next year you would do that again. You start with this amount here, and then you'd multiply that times the rate again. This is your new principal times the rate. So every year you'd get the interest would be accruing on more money. And if you do this, carry this out to any number of years, it looks like this bottom formula here. Okay, so the Okay, so how do we use that formula we just had to, this is actually kind of sort of a practical example. Now you can tell how old this book is because the interest rate they're doing here is 8%. So anymore, if you have a checking account or a savings account or a CD, you're lucky to get, 0.5% or 1% maybe. So this formula is the amount equals the principal P, times the rate divided by the number of times it's compounded per year. Compounding means we figure out how much interest you earned in whatever time period it was, add that back to the principal, and then we start calculating the interest again on that new amount that included the interest that you just earned. So the problem here is suppose $1,000 is invested at an annual rate of 8% compounded quarterly, 4 times a year. Find the total amount in the account after 10 years that no withdrawals are made. Okay, so the solution looks like this. You plug in everything to this little formula, and 1,000 times 1 plus, 4 times 10, because the number 4 is, 4 times a year. That's what N is. How many times is compounded a year? That's what N is. And the time in years is T, so we did it 40 times, and we ended up with 22,000. $8.04. Okay, so, but Mr. Oliveira, you're saying, isn't there an easier way to do this? Well, I'm glad you asked. Okay, so on your calculators, you have one of the apps that's built into it is called Finance. Okay, so you probably haven't used this before, but I'm going to show you how to use it. And if you have used it, it's been a while. So this TVM solver is what we want to do. So enter that. And this, I've got some numbers in here. Let me get rid of those. Let me put in what's happening here on this one. So we have 4 times 10. That's our rate. Our interest is 8%. Our present value, that's what we started with. That's 100. That's what the PV, 1,000. That's what the PV stands for. Our payments, we're not making any payments. We'll put that at 0. Our future value, that's what we're going to calculate in a minute. Our payments per year, that's what the PY means, is 4. And the compounding per year is 4. So we put those both at 4. Clear the what you want to figure out. Okay, to use this, I'm going to put on the keys thing here. So to figure out what you want to do on this one, you have to hit the alpha key and the solve. It's on the enter key, and it will solve that amount of money for what you want to get there. So it solves for whatever thing you want to do here, wherever you want to leave open, it will solve for it. Okay, so if you have, we'll do another quick example here. So if you want to do the how you're buying a car, let's say and you're doing a 5-year loan and you got monthly payments. So that's 5 times 12, you have that many payments. And the interest rate, say the dealer's giving you a good interest rate, say it's 2.9%. You have good credit. Present value of your Loan, well, let's say you're borrowing $25,000, getting a nice car. Payments, leave that at zero for the moment. Future value is zero, and the payments per year are 12. Okay, so that's automatically did that. We want to figure out what the payments are. So to clear the payments, how much will you pay to buy that car? A $25,000 car, 5-year loan, 2.9% interest. Hit the alpha enter button, and your payments are going to be about $450 a month. So if you can handle that, that's nice. Let me get rid of the calculator now. Okay, so if we compounded the interest all the way every second of every day, so that was only compounding per month or per year or whatever, but if we compound the interest continuously every second, every moment, you would come up with this rate of amount of how you would come up with this little formula here where you take the principal times E times the rate times the time. And the time is in years and the rate is the interest rate per year. So how much if you had 5,000, you compound it continuously? And banks actually used to do that. They actually used to compound interest continuously instead of only once a quarter or once a whatever, once a year. They actually used to do that on the interest. They may still in some cases, but not too often. So this is the calculation how to do that. This on your calculator, the E button is, let me get out of this one, the E button, let me get rid of that view. Okay, so the E button is on, so down here on the LN, the E to the X. So we want to do 5, well, I'll put the, I'll move it over here. Put the view back on. Yeah, you can't see it too well. Clear the history. 5,000, and you wanted to put it to second E to the, what did they have there? 0.08, oops, 0.08 times 5 years, okay? Same number they got there. So that's how you do that calculation on a calculator. Pretty straightforward comparing to the last one when you had the, monthly payments or compounding it per year. So pretty easy to figure out the continuous interest on that. And that's what they got here as the example. Okay, so that's the end of the lesson for today. Good luck, and I'll see you in class tomorrow.